Hello friends, welcome to follow up. Let's have a look at problem 547, number of provinces. In this video, we're going to explain a solution based on traversal. For practice purpose, we're going to provide both iterative and recursive solutions. So here there are n cities. Some of them are connected, while some are not. If city A is connected directly with city B, and city B is connected directly with city C, then city A is connected indirectly with city C. So in other words, the connectivity is a transitive relation, right? A province is a group of directly or indirectly connected cities and no other cities outside of the group. So in other words, a province is nothing but a connected component in the graph language, right? So here we are given an n by n matrix called isConnected, where isConnected ij is 1 if the I city and the j city are directly connected, and otherwise it's 0, right? So we are required to return the total number of provinces, right? So this problem actually is asking to find the number of different connected components for a graph, right? So here A connected with B and then B is connected with A. So this connectivity is also reflexive, right? So in other words, the graph is undirected, right? But here, because the adjacency matrix is already given, so we don't need to rebuild the graph by ourselves, right? So here are two examples. In the first example, the output is 2. So 1 and 2 form a connected component, and 3 forms a connected component itself. So the output is 2. So in the second example, so all the cities themselves are isolated. Therefore, there are 3 connected components. So now let's also look at the constraints. First, the number of cities is bounded below by 1 and bounded above by 100, right? So n is the length of the is connected, right? So this is the size of the adjacency matrix. So similarly, the adjacency matrix is a square matrix, right? So it's a binary one, indicating if there is a direct edge or not. And this matrix is symmetric, right? And this is due to the reflexibility of the reflexive nature of the connectivity relation, right? So with that said, basically we are ready to carry out the coding, and in between we're going to explain the logic. So actually, as a set of comments, so once we realize that this problem is for locating a number of connected components, so typically there are 2 ways to think of. One is using disjoint set data structure, in other words, the union find method. So another line is to use traversal. So you can use both breadth first search or depth first search. So here in this video, I'm going to use depth first search based traversal. So with that said, let's look at the coding part. So in the first version, so I'm going to implement that using a iterative format. So this is for understanding the finer details, right? So first I'm going to get is connected, the number of cities, and then I'm going to write a utility function. So this way it helps us to do it in a organized fashion or modularized fashion. So here a utility function. I'm going to call it DFS. So from a source, then we want to represent the connected component containing this source as a set, right? So I'm going to call it scene. It's a set. So scene is also playing the role of avoid repetition, and here is also our return in this function. And then let's initialize a stack. So here I'm using this list but I'm using it as a stack behavior of a stack feature. So in other words, last in, first out. So with that said, let's do the while loop. Well, as first I'm going to get the current node, that is as pop. That's very routine. And then if node not in sim, so we're going to add this node to the set and then examine its neighbors. So if the node is already in sim, we just continue, right? So then let's do sin add node, and then we're going to check its neighbor. So for j in range n, right? What we're going to check is if it's connected. So here we are starting from this node, and then we look at j, right? So if this is 1, right? So we're going to append this city, because this city is connected, right? And then afterwards, we just need to return this sim. So this is the utility function. Actually, this is a standard depth first search function. So here, let me give a small summary here. So sim in this function plays two roles. First, as a set, it helps avoid repetition in the traversal process. This is the standard. And in this function, or in this problem here, the sim as a set is also a representation of the connected components containing this source. In other words, the number, the participating cities in this problem. So with that done, basically we can look at the problem logic or the return. Look at the return. For this, first I'm going to initialize a result variable, right? It's basically counting how many connected components. And then let's initialize a big set to avoid repetition, right? And then we're going to scan the cities to see if we have already examined it in a traversal. So for I in range m, right? So if I not in visited, so if I is already in visited because it's already traversed, so we cannot increment the result or increment the number of connected components. If I not in visited, so we can because then I is a new element in a new connected component, so we're going to increment the result by 1. So in other words, increasing the counting of connected components by 1. And then we're going to add the corresponding nodes to the visited set. That is a visited union with the current set containing I. That is DFS I. So this way, after we finish the for loop, we are able to find the number of different connected components or number of clusters. Then we just need to return the final state of this result. So this is one version of solution to this problem. The code is not very long, so if you you look at this in the 3 parts, or more largely 2 parts. One is a utility function, one is the prepare for the return. Now, before we are ready to do a test before we make further comments. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. This is actually a typical solution to this problem. Yeah, so basically you use the stack for depth first search, or you can use a queue for breadth first search based traversal, and then you count the number of traversals you need. So the number of traversals we need, or effective traversals we need, is nothing but the number of connected components. So this is the one format. So now let's write a format based on our recursion. I'm going to call this version v1, and then basically the idea is the same, but the format of coding is slightly different. So for this second solution, let's be quick. So first, let's get this n, right? This n is length. Let's copy this part. Maybe it's better. Next, let's use a visited set. So this is a big set for us to do the counting, right? So now let's do the DFS from source. So here I'm going to use recursion, right? So basically, let's first check if source not in visited. So what we are going to do, so we are going to visited add this source, right? And then we are going to check its neighbor. So for j in range m, right? And then if j not in visited, we haven't visited j yet, and is connected source j, this equals 1. Let's write it specifically, right? This means that we should also traversal from city G. So let's do DFS here, right? And then that's the utility function. Basically, you can think of this function as a worker, right? It modifies the set, right? And then it's the same as the above, right? So we just initialize a result variable and then trying to count the number of connected components. So for I in range n, as we already initialized a visited site, let's do the check. If I not in visited, then what we're going to do, we're going to result incremented by 1, and then we are going to DFS from that source. And then afterwards, we just need to return the state of the result variable. So with that said, basically, this is the second solution format. So from the solution idea point of view, it's nothing different from the first one. And the difference lies in the coding format. So the first one is iterative, specifically referring to a stack. And in the second one, so it's a recursion format, right? It's actually a good practice. So now let's do a test. Yeah, it passes a example. So now let's look at the generic case. Yeah, it passes all the generic cases. So that's about it for this video. In this video, we provide two formats of solutions based on traversal. You can actually get other variants of the coding formats, or you can even try the union font method. That's also good practice. So with that said, that's the end of this video. Thank you.